Hello. So in this lecture, we are going to start chapter 14 about generics. So in this chapter, we are going to discuss what are generics. And then we are going to discuss generic class, generic interface, and the generic method. Okay. And then we are going to discuss bounded generic type and wild cards type. And then we are going to discuss inheritance relationship for generic class and type erasure. And lastly, we are going to do a case study about the generic stack implementation. Okay. Okay, so the first topic is about the definition for generics. So what are generics? And we know Java is a strongly typed programming language. Okay, so what this means, that means each variable must be declared with some specific data type. Yeah, so far what we learned. We know whenever you declare a variable, you must specify type. Okay, this is different from like Python. Python for variable, the variable type doesn't need to have a type. Okay, and also we know that in Java, object class is a root class, as a superclass for all of the other class. Okay, so this means that you allow an object instance to be cast to any subclass. Yeah. So an object instance can be cast to any subclass. Okay. But that's not an ideal for casting object solution. Okay. If we want to design some general purpose method class or uh, interface. So that's not ideal. So we want to design some type like a template. Okay, so basically generics is acts like a template so that it enable, we call it a type abstraction. Okay. Yeah, with the generic, then we can define generic class interfaces and methods. And with like the methods, okay, in regular method, then we replace the parameter with concrete values. We know that upon invocation, okay, for regular method, when you try to call the regular method. So, so there are some there is some similarity, okay, uh, kind of like we replace parameter with concrete value upon invocation, okay. So for generic class, interface, or method, then generic types, we call them generic parameters. So the generic types, the type parameter, they are defined. Okay, so type parameter are defined. They are defined with angle brackets. And when they are used, then we plug in concrete types to replace the generic type. So that's the idea here, okay? So you have the type parameter. So the type of parameter is within the angle brackets. And when we use then we plug in with the concrete type. So that's why here we say, okay, generic is kind of like a template. So just like in Word or PowerPoint, that this, so you have template, okay, to do some specific task. And then for a template for some category of task, then for a specific task for that category, then you can plug in the customized contents. Okay, so kind of like this concept. So regarding generic, so generic, and we are going to say it's defined with angle brackets. Within angle brackets, it's a type parameter. Okay, and when they are used, we are going to plug in with a concrete type. And in Java, we call them generics. In other programming language, like in C++, it's just called template. Okay, so previously we said generics can be applied to class, interface, and method. So let's first take a look the syntax requirement for a generic class. Okay. So for a generic class, we have accessibility and then class keyword and then class name. So for generic class, it's after that you need to have the angle brackets. And within angle brackets, you can provide, so in our case here, we use T to represent. This is the type parameter. Okay, and of course, it's not just limited to T. You can use other type like E, whatever. Okay, generally speaking, but normally we use like capitalized T or capitalized E. Okay, that's used frequently. And for a generic class, and then within it, you need to have an instance variable. The type is also T. That's a generic type. That's a type of the so type parameter. So you're going to use a type parameter also to define an instance, at least one instance variable. Okay. And you can also have instance method and class method. And their parameter can also be this generic type parameter. Okay. So here we explain T as a type parameter. So it represents some generic type. Okay. After that, you can use it to define the data type for instance variable, class variable, method parameter, and return type. Okay. And this kind of generic class, we call it a parameterized class. And but static field cannot be defined with type parameter. So here, be careful. Static field cannot be defined. Cannot. Why? Because static field, we call it a class field. Class field doesn't need, so doesn't need instance. Because it doesn't need instance. So there is no specific type. Is it? There is no like the specific type then associated with the instance type. So that's why over here, if you use a generic, the type of parameter, then that's going to be an issue. Okay. So keep this in mind. So static field cannot be defined with type parameter. Okay. And if you recall previously when we learned the nested class, we also know that a top level class cannot be declared as static. Okay. And then how about nested, static nested class? Can it be generic? Yes. So it can be. So even though static, top level static class, so top level class cannot be declared as static class, but nested class can be declared as static. It can also be some static, be generic static nested class. Okay. And but there are some restrictions for this generic static nested class. So the static field or static method within the static nested generic class, they cannot directly use the generic type parameter of the enclosing class. Okay, so this is a similar idea, like over here, static field cannot be defined with type parameter. Okay, so similar concept is because the static member belong to class itself, not a specific instance with a particular type of parameter. Okay, so just be careful. So for generic class, basically we already learned one. Okay, we already used it also quite often. If you recall the array list, each time when we try to use it, is that we needed to plug in like a string or integer something like that. So you need to plug in that. So array list in Java collections, it defined as a generic class. Okay. Then how do we create an instance of a generic class? Is that so then we need to provide with a specific data type, and we call it a generic type invocation. Generic type invocation. So what do? We just replace that generic type with some concrete class type. We call it a type argument. Okay. If you recall, like previously I explained, like array list, is that if you want to use, then you need to plug in with a specific type. And suppose you call it A, okay. Then you can do like a new array list. Array list, okay. Call the constructor, something like this, okay. So you plug in. So this is that type argument. And in Java collections, it's defined like array list. So it's the type is T, is a type parameter. Okay, it's a generic. Okay, and also be careful is the type parameter. So type argument cannot be primitive data type. It must be a reference type. So type argument must be reference type. Not reference, we shouldn't be, must be some class type. Okay, so cannot be primitive type. Okay, so over here, we just plug in with this concrete class name. Okay. So that's and then you can call the constructor to create the instance of this concrete class and of this generic class. Okay, an instance with the type as some concrete type of class. And when we call the constructor, and we also needed to specify that because this is going to be the generic class, but over here for this angle, this pair of angle brackets, then you leave it empty, okay? And it's not necessary that you repeat this type argument. Okay, so this is about how do we invoke a generic class. Okay, so we plug in with some specific type. Okay, and so class can have generic and similar for interface. We can also define generic interface. Okay. So similar, it's just accessibility, follow the keyword of interface and the interface name, and then you have the type parameter. You provide a name for the type parameter. And over here we use T, okay? And if you recall previously when we learned the comparable interface, is it whenever we try to use it, so we do like implements, like a comparable, is it? And maybe over here we define, yeah, just like that house. You can implement this comparable, is it? And following that, you need to plug in the type argument with some specific type. So over here, it's consistent with whatever this concrete class is. Okay, so this comparable, then the concrete, the type argument is going to be the house. Okay. And if you recall, for the comparator interface, we also previously we also learned, is it? So similar, and we define like some class, we call it comparator by area, and we are going to implement this comparator, and then over here you plug in with some specific class, concrete class. So that's the interface. So similar concept like the generic class. Okay, this is about generic interface. We also learned, yeah, like a comparable comparator interface. Okay, so we learned the generic class, generic interface. So for method, it also allows generic type. Okay. So then similar as previously, so accessibility for the class, static or not, and the return type and method name. So before return type, you provide the pair of angle brackets, okay, and the type parameter. And then for the parameter list, it can be empty or list of uh, some other parameter also allowed, and as well as some for this um, generic type for the parameter. Okay, so you can also use the type argument as your parameter for the parameter type. Okay, so that's the syntax for the definition of a generic method. Okay, so you need to provide the parameterized type before the return type for the method. And for the parameter list, it's either empty or the parameter, some parameter the type can be the parameterized type. And when we call a generic method, we have two options. Okay, one is involve explicitly specify the type argument, okay, before the method name. So this is one option. So this is different from what we have learned for regular method. Okay, so before the method name, you specify the type argument. Okay, or the other, just like our regular method invocation, so you don't specify the type. This, if we don't specify type for a generic method, then we call this type inference. Okay, type inference. So for the type inference, then it will allow compiler to determine the appropriate type based on the context. So for invoking a generic type, we have these two options. So provide the type argument or not using type inference. Okay, for the previous discussed, like just angle brackets and this T, for this kind of generic type, it's unbounded. Unbounded generic type. Okay, so you just plug in some type argument. Okay, we can also restrict a generic type to some specific category. Okay, so that's also allowed because a class can have subclass, is it? Yeah. So like over here said, example, you can restrict the generic type being some number type or any of its subtype. Okay. Or like an animal type and its subtype. Yeah. So sometimes we probably need this, is it? So this is called a bounded generic type. So for bounded generic type, it's some type and its subtypes. So that we are allowed. Okay, we allow the type and its subtypes. And then in this case, there is another keyword we needed to use, extends. Okay. So then with this, it's bounded type to specify upper bound. So here we specify the upper bound. So the syntax over here, then it's a little bit of more complicated than the previous unbounded type. So you can do T. Extends, you specify some super type. Okay. Like an animal, you can do like T extends animal. Then T can be animal or its subtype. Okay, so that's the idea. We call it bounded. So for the definition, then you needed to use the keyword extends. Okay, so it allows provide upper bound over here. So it allows the type and its subtypes. So that's the idea about bounded generic type. So for bounded generic class, we also allow bounded generic method also allowed. Okay, so bounded. So then in this case, before the return type for the type parameter. So in the type parameter for generic method, then you do the extends, specify some super type. Okay. And then when we provide the parameter, some specific parameter, as said, then for that t, you can just use t. Okay, you don't need to do the extends, the super type. You don't need to repeat it. So this is for the method, generic method, bounded generic method. Okay, before we move to the next topic, so here's a photo for a national park, pretty famous one. And here's another photo from the national park. And we're going to disclose it at the end of this lecture. Okay, so the next topic is about wild cards type. Okay, so wild cards type, so we use question mark within that angle brackets. Okay, so what you do is like this instead of that t or t extends some super type. Okay, so this represents a wild card type. Okay, but be careful, wild cards type, it's not a generic type. So it cannot be, so wild card type cannot be used to define. So cannot be used to define class, interface, or method. Okay, but they are applicable for method parameters and also local variable types or fields, and even return type. But generally, we don't recommend, okay? So not to recommend for return type because it can cause some confusion, okay? And when we try to use wild card type, we must use these angle brackets, okay? And also wild card type, even though you can use it, okay, for the method parameter, but you cannot use like something like this. So this is allowed. So wildcard type is not allowed to be used for variable declaration. So this is not, okay? And also for generics, we learned they support unbounded and upper bounded. Okay. For wildcards type, so it's more flexible. They support unbounded, upper bounded, and also lower bounded. Okay. So when we study our example, we will understand that better. Okay, so here to give us the syntax to use wildcard types. So for unbounded, then it's just the question mark. For upper bounded, then you do similar question mark, then extends superbound. So it can be the superbound or any of its subtype. So this is just like the upper bounded, so the bounded generic type. Okay, but it also allows this. Another so question mark, and then using keyword super, and then some subtype. Okay, so in this case, this question mark, it can be this subtype or any of its super type. So some subtype or some of its super type. So it's more flexible for wild cards. So when do we use wild cards then? Is it it's It cannot be used to declare class interface or method for generic, for the template cases, is it? So when we use it, we use wildcard type with non-generic method. But we do need some parameter of unspecified type. So it's non-generic, but we need the parameter be more flexible of specified type. Okay. So do not use wildcard type when the exact type is required or needs control. Okay. Like when we create some instance, new instance, we don't use wildcard types. Okay. So here it provides us some guidelines. When should we use wildcards type? Okay, and because of the generic class, then how it impacts the inheritance relationship is it? So let's take a look. So here you have a generic class, and then you have a generic subclass. Okay, so both are so it's defined as generic class, generic subclass. Okay, so then in this kind of inherited relationship, even though it's generic class, they are still maintained. So it still means is a relationship. Okay. So if we plug in, okay, with some specific concrete class A, then their inheritance relationship is still maintained. So it's still meet the is a relationship. But in this scenario, so class A and class B relationship are the inheritance relationship. Okay. So class A is a superclass for class B. And then you say, okay, we have generic class. And then when we plug in with A, the other we plug in with B. So will this two relationship still be the inheritance relationship? Then the answer is no, it's not. Okay, so be careful. So A and B has inheritance relation, is a relationship, doesn't mean when you plug in A and B to a generic class, they have the generic, they have the is a relationship. No, okay, because the class, generic class, this class, it's the class itself. Is it? When you just plug in this different concrete class, then it will not um, it will not change the relationship between these two classes because basically these two classes should be the peer class relationship, doesn't have the inheritance relationship. So that's regarding inheritance relationship. Okay, another term or concept in this chapter is called type erasure. Okay, so what is that? And Java, we know it's a strongly typed programming language. So that means any object or some variable, they needed to have some type. But here we learn, okay, we learn generic. Generic, so it's unbounded or bounded, is it no matter what, it's not some specific concrete type. So then how Java compiler to uh, deal with it because it's a typed programming language, is it? So the compiler uses a process. So the type erasure is a process. Okay. So what it does, the compiler then will replace the undefined type parameter with its bounded type or object if it's unbounded. So if it is just this t, then it will be replaced with object. Okay. And if it is t like extends like a super type, is it? Then it will be replaced with that super type. Okay. So here it gives us an example. So like for this, okay, generic class type, and then T is unbounded. And within it, the instance variable T type is T. Okay, so basically the compiler, so this is called type erasure. So it will be replaced. So the compiler will replace it with object. So T will be replaced with object. Okay. Another is like over here, we have this bounded type. Okay. And we also have an unbounded type T. So when the compiler does the compiling, it will use the type erasure to replace T with object, and that U extends the number that will be replaced with just that super type, okay, the number, okay, in this case. So this is a concept about type erasure, so that it consistent with Python is a strongly typed programming language. And similar for the method, okay? And like this method, okay, is ascending. And over here, this is represents generic, but this is bounded generic because the T must implement the comparable interface in this case, okay? So that's why here it said extends this comparable, and within the parameters just T, okay, you don't need to repeat that. Then in this case, what's going to be replaced? So over here, we don't need the type anymore. Okay, just here, just like the regular method. But within the parameter, then you can just replace that t with comparable. Okay, with its upper bound type. But over here for method overloading, okay, method overloading, so the concept is the method name is the same. So methods name are the same. But we said with different signature. So the signature including like a parameter and a return type. So that's about method overloading. Okay. Overloading, but it has a requirement of parameter type must distinct after erasure. Okay, after the type erasure for the generic method. So different type of argument for generic parameters do not create distinct types. So be careful here, okay? So different type of argument for generic do not create distinct types. So then when we try to write a method, overloaded method, we need to be careful. Okay, so here it gives us an example. We have this method, is it? Within this method, we have this array list, and the type is wildlife, okay? And so this is, so then you may ask, how about this, okay? And here we still have the same name, but for this parameter, this two parameter, for this one, then what we plug in is the animal array list. Here's a wildlife array list. So will this to be considered as method overloading? No. No. This will not. So, so this will have the issue, okay? So because after we do the type erased, both will just erased to array list, array list, okay, for this parameter. So then there is no difference, is it? So then it cannot meet this different signature requirement. So that's not going to work, okay? But if you have one as array list, another suppose, okay, you call it a queue, then that's fine. That can be considered as a overloaded method. Okay, so this is about the type erasure. So we understand it. Okay, so okay, then the answer for the two photos is the Yellowstone National Park. Okay, so that's all for this lecture. In our next lecture, we are going to start discussing our coding examples. See you.